Wave 40 deals with electronegativity, and its definition is the attraction for electrons in a chemical bond. Please note that whenever we need to find the electronegativity of a particular element, we can always use Table S. Table S lists the electronegativity of various elements on the periodic table. In general, metals tend to have weak electronegativity, values closer to 0, whereas nonmetals tend to have strong electronegativity. And the reason why, if you recall, is all atoms are trying to achieve stability. And it's a lot easier for metals to lose electrons and nonmetals to gain electrons in order to achieve that octet. Whenever we want to find the degree of polarity or the amount of sidedness that occurs within a chemical bond, we can look at what's called the electronegativity difference. If the difference between two atoms is relatively the same, they're going to have a low electronegativity difference. So most of the electrons will be shared equally. Now imagine one of the atoms has a higher electronegativity compared to the other. That atom is going to pull the electrons closer toward it, and as a result, it's going to have a partial negative charge and a partial positive charge. This electronegativity difference results in electrons being shared unequally. Polarity just means unequalness, basically. If the electronegativity is sufficiently large, such as between 2 to 4, we'll get what's called an ionic bond. Basically, the electrons are being pulled so hard by this atom that the electrons essentially get transferred from the electropositive atom to the electronegative atom, and this atom forms ions because it just obtained electrons from the other atom. So we have a positively charged with a negative charge. So remember, when it comes to electronegativity, we can always look up values on Table S. Let's see if we can apply this property to answering questions. Which term represents the strength of the attraction of an atom? The strength of the attraction an atom has for the electrons in a chemical bond. When you are talking about the attraction for electrons in a chemical bond, you should immediately think electronegativity. So the answer is 2. An atom of which element has the strongest attraction for the electrons in a bond? If you look up the electronegativity values on all these answer choices in Table S, you'll find that chlorine has the highest electronegativity. As a result, it's going to have the strongest attraction for electrons in a bond. I'll also show you a trick that you can use relative to the location of an element on the periodic table in just a moment. The equation below represents a chemical reaction at 1 atmosphere and 298 Kelvin. 2 hydrogen gas molecules plus 1 oxygen molecule yields 2 water molecules of gas. Compare the strength of attraction for electrons by a hydrogen atom to the strength of attraction for electrons by an oxygen atom within a water molecule. When you think strength of attraction for electrons, you should think electronegativity. So essentially, it's just asking you to compare the electronegativity values of hydrogen and compare them with oxygen. When you do that, you'll find that the strength of attraction for electrons of hydrogen compared to oxygen is 2.2 compared to 3.4. So oxygen has more attraction for electrons within a water molecule. This is what causes water molecule to be slightly polar, meaning oxygen has a slight negative charge because those electrons are being pulled closer toward that atom compared to hydrogen, which has a lower electronegativity. So we would say that this molecule is polar covalent, but we'll get to that in a moment. Which property is used to determine the degree of polarity between two bonded atoms? If we want to establish how polar a particular bond is, we have to take what's called the electronegativity difference. If the electronegativity difference is great toward 4, we get what's called an ionic bond. If it's weak, the difference is closer to 0, then we get a non-polar covalent bond. So we need answer choice 2 as our answer. Which atom has the greatest attraction for electrons in a chemical bond? One trick that you can use for problems that involve assessing electronegativity is noting that anything toward the top right corner is going to show the greatest electronegativity. In general, fluorine has the highest electronegatividity. Group 18 doesn't have any electronegativities, if you look these up, because they're already stable and don't desire any more electrons. So fluorine is the most electronegative atom versus francium, which is the least electronegative atom. As a result, anything toward the top right corner will have the highest electronegativity. Alternatively, you could just look up the values and you'll see that oxygen has the highest electronegativity, or oxygen is also closer to the top right-hand corner. Therefore, it's going to be the most electronegative atom. Based on table S, an atom of which element has the weakest attraction for electrons in a chemical bond? I'll hold this chart up, so that you can use it to answer this question. Conveniently, all these answer choices are in the same group: sulfur, selenium, tellurium, and polonium. And as we go down a group, electronegativity decreases, so it just so happens that polonium will have the weakest attraction for electrons. As a result, the answer is polonium, answer choice 1. Alternatively, you can look on table S and find polonium's electronegativity, and you'll find that it has the lowest value compared to all the others. Next problem. Which element has atoms with the strongest attraction for electrons in a chemical bond? I'll have this chart up just so that you can use it. Strongest attraction for electrons is basically asking for the highest electronegativity. So for this problem, you should have gone with fluorine, answer choice 3. So when it comes to problems involving electronegativity, please note that it means the same thing as strength of attraction for electrons in a chemical bond. They're the same exact definition. Electronegativity values closer to 0 are weakly electronegative, and values closer to 4 are strongly electronegative. The nonmetals tend to be electronegative because they want electrons, whereas the metals are weakly electronegative. They prefer to get rid of their electrons because the pull isn't that hard. We can also use the electronegativity difference to establish the degree of polarity. When the difference is closer to 0, it means that the electronegativity values are closer to each other, and as a result, electrons are shared equally. If the difference is great, then one of those atoms is going to be pulling the electrons closer toward it and result in a polar molecule, where you have a partial negative charge to the atom that's pulling electrons closer to it, compared to the atoms that are weakly electronegative and will have a slight positive charge. When it comes to locating the electronegativity value, you can always use the periodic table. Atoms that are closer toward the top and to the right are mostly electronegative. Why? Because the size of those atoms tend to be smaller, and therefore the electrons are going to be pulled closer toward that nucleus. Hopefully this was helpful, and thank you for watching.